Hi guys, welcome back. Today I'm going to talk about some of the Python basic and talk about a little bit about the federal tax. I am a W-2 worker in the US. There may be more. There are two employment types that I know is the W-2 and the 1099. And every year on April 15th is tax day where you have to file your tax. Why do we have to file our tax? It is because for 1099 employees, they don't typically withhold their tax every paycheck. So they have to file the tax to pay their federal income tax. And for us, the W-2 workers, we have to make sure that the money that we're withholding is enough or not enough for the tax year. And anyway, so today, to talk a little bit about the Python very basic data frame and visualization. So I have a CSV file with the um, with one, two, three, four, five columns. Uh, these are the things that I grab online somewhere. Disclaimer, please do not use this information for your tax year because um, I do not know which year this come from or anything. These are just dummy data I use to show you things that we can do with Python. And first of all, I check for any null values in the data frame, and this column right here has, and the entire column is null. So, well, how do I know it's the entire column? Because I know there's 28 rows in the table, so I'm just gonna drop it. Um, as we can see, these are all string columns, and so I want to process it where I can get number out of it so I can calculate the taxes later. Schedule, there's four schedule total, X, Y1, Y2, and Z. X is for single people. Y1 is for marriage, but we file jointly. Y2 is for marriage, but we file separately. And Z is for head of the household. What's the difference between head of the household and the single people? You said, but we're going to talk about it later. So I want to clean up the column name a little bit by using just a very simple way. So the tax table is a data frame and it has the attribute columns. You can assign any list to this, to the columns to rename the column name. Uh, and next, we have so lower mean lower limit, upper limit, and the calculation rule. And so we see that the lower limit and the upper limit column has this dollar sign and also some comma it's standard HTML web page data that I grab it from. And so I will write a function just to remove this thing and to change the type of these two column as a integer or float. For the calculation rule, I want to extract the percentage and the tax starting point for some of the level. So just for fun fact, federal tax in the U.S. is marginal, which means that once you hit to a certain level, you're gonna have a different percentage taken out of that interval. And so if your boss is telling you, hey, I'm going to give you a promotion where it's going to put you at $200,000, don't be scared that you're going to pay 32% tax on the whole thing. No, it's 32% on the amount that's above $182,000. So all in all, I want you to enjoy that 68% that you have, the 68% that you get from that 16,000, from the $18,000 that you're gonna get. All right, yeah, so it's just a simple function to replace the no limit to the um, NumPy infinity, and if it has a dollar sign or a comma, just take it out completely. Percentage, I use regular expressions. So I group things and I put in a dictionary. So I put in a group dictionary. I'm gonna show you in a little bit. And I use that to function to the first function to the lower and upper limit, and the second function to the calculation rule. I keep the column extract for you to see. So what regular expression does is give me a dictionary with the percentage and the amount. And when I do the JSON normalize function, it's gonna extract it into a separate column. This null is because there's no lower limit detected in the calculation rule. So there's no, it should be, if it's uniform, then it should be a 0 plus whatever number amount over 0, but it's a null. So we're gonna replace that null with a 0, drop the calculation rule and extract column, and now I have a table with the schedule, the lower and upper limit, the percentage for that interval, and the starting amount, starting tax amount. Like I said, I want to change the lower and upper limit into a float. I change the percentage to an integer, and the amount to the float. And so now I'm having the schedule column is the only column with the string object. All right, next I have a tax old function where it takes the income, the tax table, and the schedule default as single person. And it will just create, then it just use that calculation rule and give me the number. So here's an example. If you make $100,000 and you file, and you file marriage file jointly, this is the amount that you have to pay. These are taxable income, so I shouldn't say that if your taxable income is $100,000, this is how much you have to pay. Why do I have to say taxable income? Meaning, let's say if you make $100,000, you can deduct about $25,000 as a Y1 schedule to your standard deduction, meaning that all of your food, your standard of living, basically. So you don't really pay that much if you make 100,000, but I'm not going to encourage you to use this notebook as your tax guide, so I'm just gonna leave it as vague as it is. All right. So next, I am making an income table. I use time just to see how long it takes for for the shell to run. And this is a great thing because then you can try different method, because there's multiple ways to roam. And so you will ended up with a lot of tools in your hand, and you're like, okay, what tool do we want to use? And time is a good metric for you to determine, okay, what method I'm going to apply on any function. And so I have 4 schedule total: single, marriage find jointly, and marriage find separately, and head of the household. And I generate this table where if your taxable income, I should say taxable income, but let's just understand it's your taxable income or adjustable gross income, AGI. I believe that was, this should be, so let me write a income equal adjusted gross income. Yeah, so after all the adjustment, this is what you have left and what you are going to pay tax on it. And here is a little uh, figure that show what is the tax, that we are paying for each income level. You see like each of the, you see the single and the head of the household is writing each other till the end, so it doesn't even separate a little bit. Why do they have two schedules? Well, it's because as a head of the household, you have independence, and you can, when when it makes a difference is when it's around this little jump right here. Let's say if you make $230,000 and you are able to claim some of your independence, that will put you back into the last bracket. Instead of the single worker, they don't have that. They don't have any independence to claim. Um, and then which is, which, and then you're gonna see the marriage file jointly and the marriage file separately. So let's see if in this instant where if we assume that the other person is not working, somebody says stay at home mom or stay at home dad, you can see if the other spouse are making, so we're gonna compare the orange line and the green line. So the orange line is always below the green line, right? However, there is a certain amount level over here where the orange line is above. And so if that one person that solely provide for the whole family and they're making above $700,000 or $800,000, then it make more sense to file separately, which means the stay-at-home mom or dad doesn't have to pay any taxes or even get some money back because of the independence. The other person, the sole provider of the family, is paying less tax. So let's say this at 800,000 filed jointly will be around $500,000. So this is the adjusted gross income, not your sole income on here. Again, do not use this video as a guide for your taxes. Anyway, so then I was like, okay, what is so where would the family, so let's say I was like, okay, so in what instance would two people who's married and they decided to file jointly or separately? And so I create an income table where I do a Cartesian joint, and I only take the income where the X is larger than the Y. So whoever making more money is the X and less money is the Y, and both people generate income. And well, that way I narrow down my data frame is a little bit less than what it should be, and so my processing time is a lot better. Okay, so I use that information to generate, okay, what is the total taxable income on both? And if they do joint, what is the tax they owe? If they do separate tax, what is the total? And here is the little visualization that I have. Is you can see the joint is one, and the joint one is blue, and the orange one is the joint, and the orange one is separate. So in most of the instant, the orange one is above the blue one, as you can see, but there's some instant there's a blue one floating on top. And so now I was like, okay, so what is so how many instances that doing joint is not beneficial? So I use the joint and I minus the separate tax, and there are 510 instances compared to 3,000, which is about 15% of total instances in my data set. And I sorted value by the differences between these tax. So if your family making $161,000, but one person making $360,000, then it makes sense to file separately, because then you save 107,000 total, and it goes all the way down to 72.75 cents. So at this point, the family is going to ask themselves, is it easier or harder to file separately? Like, what is the logistic? What is the And so I was like, okay. So I was like, what is more granularity that I can do? So I plot the difference between the income between X and Y, and the difference in file separate or jointly. So if any of these loss level, I would say, there is a delta between the income of the spouses and what is the total income, right? Different. So this is the different, and this is the income different and the total income. So the orange one is the total income, and the plus sign is the income different. So if you have a total of, again, if you have a total of 360,000, and your delta between you and your wife is 360, or roughly 360,000 as well, then um, file separately. And so we have a bigger lump over here where, okay, the total income is in around 600, is around 6 or 700, 600 to 700. We have a big lump over here. There's a big lump over here with total gross taxable income is 300,000 to probably like two something to 400,000. That would save the family around $50,000. Anyway, so that's how I use Python, very basic Python, and data frame, and Matplotlib to serve my curiosity. And this one is on federal tax. I hope you enjoy this video. I was planning to do this as a faceless account, but I felt like maybe I should be present more in these video. Anyway, if you enjoy the video, don't hesitate to give me a thumbs up, or that will encourage me a lot. Thank you, and I'll see you next time.